I know.
On Friday.
Okay. Lesson 2, extrema. Okay. Talking about extrema. I've already hinted at several things that we're going to talk about in these next couple of lessons about how derivatives connect with extrema. Okay. And we're going to look more at that today. So when we talk about extrema, first of all, extrema, when I say extrema, your brain has to think mins and maxes. We've learned something. Yes. Okay. Now, so max and min values of a function are called the extreme values or extrema. Interesting. Singular is extremum. I'm not sure I knew that. Or let me rephrase that. I obviously knew it because this is not the first time I've read these notes, but I'm not sure I remembered that. How's that? Okay. Extremum, huh? Now, the process used to find them is referred to as optimization. Okay, so I don't use that vocabulary word a lot, but if you're being asked to optimize, you're looking for your extrema, you're looking for your mins and maxes. There'll be times when we want to find the min and max for an entire domain or just on a particular interval. So we're going to learn how to use calculus to find the extrema instead of just a calculator. In other words, you can always graph something in your calculator, and you can go to second calc and do your min and do your max, right? But we're looking at, okay, how can we, on the non-calculator portion of the test, how can I find my extrema? Okay, so a little bit of vocabulary here. If f is a function on an interval I, then y equals f of c is the absolute or global maximum, okay, if and only if f of c is bigger than f of x for all I. So the idea here, and this is absolute is usually the word. If it's an absolute max or an absolute min, this is all fancy speak for saying the absolute highest point or the absolute lowest point. There can be other mins and maxes, but they will not surpass the absolute. Okay? Global, I don't feel like we see the word global a lot, even when dealing with AP tests and stuff, but a global is equivalent to. Okay? As opposed to relative. Okay? So I'm going to skip down and talk about these definitions real quick, and then we're going to go back to example 1, because as we go through and talk about the extrema here, I want to talk about what type of extrema they are. So absolute or global extrema, the highest or lowest y values on the graph of a function or on a specified section or domain. Okay. Relative, and you guys have seen this vocabulary before. Relative or local, I feel like you do see local. Those are y values on the graph of a function where the function changes from increasing to decreasing and vice versa. So a relative or local extrema is any min or max. Okay, so there can be multiple relative extrema, but there can only be one absolute max and one absolute min on a given problem. Okay, so let's go back and look at example 1.
I have a question. What
Yes.
if it's like a sine graph and they're all at the same?
Like a sign chart where we just know positives and negatives.
Yeah, where it's like they're always like
Like the
One.
horizontal asymptotes.
no, where they're always at 1.
No,
Yeah, it would
the-
go up
when
to
it goes
one,
up and
and then go down to
and
1,
down,
and
they're
then
all
go up to 1, then go down to 1.
So you're talking like sine and cosine graph?
Yeah.
So sine and cosine graphs would have lots of relative mins and maxes.
Okay.
They would not have an absolute min or max. That's my thoughts on the vocabulary. Is there would not be an absolute because there's never one that is higher than all the others
Okay.
or lower than all the others. So you would just have multiple relatives. Does that make sense? Now, in all honesty, when you are asked what is the extrema, what is the value, the extrema that you're talking about is the y value. Okay, so that's something that you might want to make a note about. Here we go. Come on. Nope. Okay, let's see. Something you might want to make a note about when we talk about extrema. Extrema are y values. There we go. Okay? Extrema are y values. If you're asked where an extrema is, that's the x value. But if you're asked what the extrema is, that is the y value. So, okay, so backtrack to 1 here. The graph is shown. Determine the extrema of h of x on the interval. And as we talk about these extrema, I want to talk about if they are relative or absolute mins and maxes. So, what do you see?
Yeah.
D and E are absolute. And D and E is an absolute min. D is an absolute min. E is an absolute max.
Okay. So if we talk about the point at D. So this is the point at x of D, x equals D. It is, can we agree it's absolute?
Yeah.
And it's an absolute minimum. Now, officially, if I'm going to, it's located at D, the name of that point, let's see, this function is h, isn't it? I was getting ready to say f. So the name of that point is h of D. So there is an absolute min at h of D. Interesting enough, I didn't catch it last year. In my notes, I have it listed as f of D. Now, you understand what I mean, though, right? The only reason I'm being specific in saying h of D is because that's what the graph is called. So I should use the appropriate name.
Why did they mix up the F and the E?
Just to torture us. Okay, that's our absolute min. What else did you say?
E.
Okay, so right here at E, an abs max, and that is h of E. I still want to write f of E, but okay. What else do you see?
Multiple relative mins and maxes.
Okay, give me a specific.
Relative max is A and C.
Okay, so at C, we have a relative max, and that relative max I would call is
HC.
h of C, because that is the y value, right? You plug C into h, that is the y value.
I'm not so sure about A.
I know A and F. I don't know what to call them. They're endpoints for me.
And that's why I was just looking at my notes too.
They have solid circles that go.
What about B? Can we talk about B first?
So, okay, fine. Let's get B out of the way.
B's relative min.
Yeah.
Are we on board with that one? Here's what I'm going to say about A and F, okay? While I understand, in a way, yes, we do need to consider them relative mins and maxes. I'm not going to list them as such, okay, because they are endpoints. Yes, they are included. Okay, yes, they are included. And here's what I will talk about. When we get, I don't think it's in this lesson, it's in one of our upcoming lessons. When we start talking about trying to find all of our mins and maxes without graphing them on the calculator, right? And we're looking at our critical points. Okay, we'll be talking about critical points. One of the things is, if it's on an interval, you always test all critical points and end points when you're trying to find like the absolute min or max. Because could those points, if nothing else is higher or lower and we're on this specific interval, could those points take the category of absolute min or max? Yes. Okay, so we're not going to totally overlook them, but I'm not going to list them for the purposes of finding extrema. Got it? Okay. Next page. A little bit of definition before we go on to example 2. If there is an open interval containing C on which f of C is a maximum, then f of C is called a relative maximum of f. This is kind of some of the vocabulary I just went over, isn't it? Okay? If there's an open interval containing C on which f of C is a minimum, then f of C is called a relative minimum of f. Okay. Let's see. Noteworthy thoughts. When we say open interval as opposed to closed interval, open interval means the endpoints are not included. If we talked about closed interval, then it'd be equal to endpoints are included. with that. That is, C will be contained somewhere inside the interval and will not be either of the endpoints if it is an open interval where C is just between A and B. A relative extrema is slightly different than absolute extrema. All that's necessary for a point to be a relative max or min is for the point to be a maximum or minimum in some interval of x's around it. So basically, if it's a relative max or min, it has to be either lower or higher than the points on either side of it. Okay, doesn't matter about the rest. And there can be smaller or larger values of the function at some other location, but relative to x equals c, that point is either smaller or larger than the values in the neighborhood of c. Kind of what we've already talked about, yes? Let's do example 2. Okay. Consider the graph shown at the right. This time, to bug Kylie, we get to talk about g of x, right? H of x, g of x. Hey, next one we get to talk about f of x.
Why don't they always just have f of x?
Okay. And I would say because if you have multiple functions within one problem, they
That's
can't
fine.
all be f of x, but you just want all the singulars to be f of x.
She just
Yeah.
wants to.
Okay,
And I just want to complain. I haven't done it all day.
okay. Get the complaining going then. Okay. So consider this graph. State the relative extrema.
Oh, it's next to the fourth graph.
All right.
State the relative extrema. Give me a relative extrema. I want to know is it a min or a max?
2,
Negative
2.
3, negative 8.
That's not relative.
That's not relative.
That's absolute.
So,
1,
2.
4.
Oh, yeah, that is. Sorry, guys.
Now, and technically, depending on the definition, if we wanted to list all relatives here, we could include the absolutes. Now, however, what is question B asking us?
Yeah.
Question B is asking for the absolute. So let's just go with the relatives that are not absolute.
Pay attention.
2, 2 is a relative max.
Oh, no.
4, 0.
Okay, now,
Relative min.
hold on, I'm going to state this differently.
Okay.
There is a relative max.
At G of 2. Right?
Well, okay, I'm going to say there's a relative max of 2. And where is that relative max of 2 at?
G.
X equals 2.
Oh.
That's what. So in other words, the key to remember, I just mentioned this, your mins and maxes, your extrema are y values. Okay, so don't forget.
We just write G of 2.
It depends where. Because g of 2 would be what goes right here. But if they give you the value, you need to use that value. Okay? This right here, x equals 2, that's your x value, your location. So you can't say there's a relative max of 2 at g of 2 because those are saying the same things. Okay? What else did you guys say?
Relative in of 0 at x equals 4.
Now, I hope he was right because I wrote it without checking it.
Yeah.
A relative min, the min value is 0, and it's located at x equals 4. Are we there?
Yep.
Okay, so we've got that one and that one. Of course, I started with the 2, 2, 1, which always confusing which 2 is which. Okay, anything else?
Would 5 3 count? Or is it no, since it's not a count? Or-
Is it a min or a max?
No.
No.
I don't think it
Nope.
would be.
Would we not consider 2 2 a absolute max if it's
No.
Going-
Infinite.
But
so
mine-
since it's infinitely up, we don't count that as it. Okay.
In other words, is there going to be an absolute max here?
No.
No. And that's where we'll talk about here that because, so now, here's the deal. If we had endpoints here, we could come up with some absolute max. But because either side is going infinitely up, there will never be an absolute max. And that forces this to become a relative max.
So if it was infinitely down and infinitely up, there wouldn't be an absolute anything.
Correct. Okay. Yeah. In other words, like if we had like a cubic graph where
Yeah.
we could have relatives, but we wouldn't have absolutes.
Okay.
Okay. Okay. Good. Good, we're getting it. Let's see. Considering the domain for G, what are the absolute extrema of this function? So what do we know?
Absolute min at
Negative
negative 8 at x equals negative 3.
Okay. And I believe, yeah, I have written in my notes what we just talked about. Absolute max does not exist because g of x is unbounded above, if we throw in a little bit of vocabulary. Remember, if something is unbounded, it's going infinitely in that direction. Okay, so unbounded above means this graph goes infinitely up. So absolute max, I'm going to say DNE to save myself space, because g of x is unbounded above.
Danny.
Okay. 3. Consider this graph on the interval from 0 to 12. Find relative extrema.
Relative min.
10, 2.
At
Okay, 7. Nope, that's. Gosh, that is a max again. Or an absolute. I just need to.
Why did I do this differently?
I'll be quiet.
What's the difference?
I'll be quiet.
Seriously.
Well, okay, so when I'm trying to figure out why did I do this differently, I didn't use endpoints. I'm not sure why, but I guess I'll use it as a reminder. On the top, on example 2, we just listed our relatives as the one non-absolute. And then on B, we listed the absolute. On this one, on A, I listed all mins and maxes as relatives. And then I specifically listed the absolutes on B, which those absolutes then were repeats from your relative list. Now, what is the difference between example 2 and example 3 that's made me do that? And I don't know. Okay, what did you guys already discuss?
relative min of 2 at x equals 10. If that is
You with her?
Yeah.
That one's definitely a relative, yes, no matter what. Relative min of 2 at x equals 10. Okay? Because that is the ordered pair, 10, 2. With that in mind, what else do we notice?
There is also another relative min. Oh, wait. There's an oh, I guess it's relative.
Go ahead and talk about absolute while we're here.
There's an absolute
At
max.
7, 7.
At 7, 7.
And another one at
There's an absolute min
negative.
at 2, negative 2.
That's absolute max. That's
There's an absolute max of 7 at x equals 7. And there's an absolute min of negative 2 at x equal 2. Now, I have, as I said, 3 written up here, and that is the idea because, and I'm, whoops, goofed that up. These can also be considered relative. Okay? So, be aware of that. I'm not sure why I listen. I don't know. Sometimes don't remember my train of thought at the time.
Oh, that was harder than I thought it was. Oops.
Okay. We have the idea about our maxes and mins, yes?
Yes.
Okay. We've talked about IVT this year. We've talked about MVT this year. Now we
There's
get
another one?
EVT. Yeah, there's
How do you
EVT.
get these all mixed up?
And there's MVT.
Very easy. Okay, so IVT, MVT, and now EVT. So, what conditions would be necessary in order to have both an absolute max and an absolute minimum? And so here we're going to talk about EVT, which is the extreme value theorem. Okay, so let's get through the words. If f is continuous on a closed interval a to b, then f has both a maximum value and a minimum value on the interval. Okay, so basically, any graph on some interval from beginning to end is going to have a max and a min. I'm sorry, I can't help but laugh because, like, in unison, Kylie and Sophie both turned back and just gave you a glare that you were ignorant of, but it just made me laugh. So, okay, so EVT on some interval. Who knows what the graph does? Does it go up and down? Does it just do one big loop? Who knows? Or one big, hill or valley? But the deal is there will always be some max and some min. Okay? Now, could that max or that min be like a starting or ending point? It could be. Okay? And that's when because of what happens when we're specifically talking about on an interval. Okay? So, it's probably going to, extreme values can occur at interior points or end points of an interval. A function may have both maximum and minimum values over an interval, or either a maximum or a minimum, or no extrema on interval, and we're going to explore some options. Okay? When the hypothesis is not met, either continuity or the closed interval, there's no guarantee of EVT. Okay, so this is just stating that basically, so for instance, what's the if part? If it's continuous. If continuity doesn't exist, you can't guarantee the end part. So we can't guarantee the EVT part where it says there's a max and a min.
So this one doesn't have to be differentiable, it just has to be.
It just has to be continuous.
Okay.
Okay, and that's, when it comes April and we're reviewing all these, we've got to separate them all out, right? Okay, so correct. This one is only continuous. Okay, now, what I was saying here, if the if is not met, so if the continuous is not met, there is no guarantee. However, could they both still exist?
Yes.
They can both exist. It's just by EVT, it's not guaranteed to exist. So, okay, 4a. For the graph below, explicitly state where the hypothesis of the EVT fails on the interval 0 to 3. Then determine if the function has an extrema on the interval. So, did you catch how that read?
Where it fails.
Yeah. Explicitly state where the hypothesis fails. So are any of these going to work from 0 to 3? No, they're not going to work. And then we're still going to talk about extrema.
I'm sorry, what is IVT? Can you just, what is-
Intermediate value.
Thank
That's interesting.
Intermediate, and that was back early.
Yeah.
I had type this in.
I don't remember what chapter, but
Intermediate.
was it in chapter 1?
Yeah.
Okay.
Intermediate value.
Intermediate value theorem, yeah.
I just couldn't remember the first word, so all three of us were looking.
Should have known there was something. Okay, so A. Where does EVT fail?
1, comma,
Okay. And I guess,
3. There's a point and jump.
yeah. So it's not continuous at 1. I didn't do this in my notes right because I just have the EVT does not apply since f of x is not continuous. I think I just read this as does it apply, but where? So I'm going to say not continuous at x equals 1. Good enough? Now, determine if the function has extrema. And specifically, I'm talking about, I think, absolutes for the most part here. What do you see?
I mean, an absolute max is
1,
4.
4.
Okay.
And then absolute min is,
I'd say like 0, 1.5.
yeah. Good job.
Okay, absolute max
A 4 makes it equal.
of 4 at x equals 1. Absolute min,
Of 0.5.
my notes say 1/2. At x equals 0. Okay. B,
Not continuous at x equals 1.5.
okay. So EVT fails at 1.5. What do we have in terms of extrema?
Absolute min at. You can go yours first.
Absolute max at 0, 4.5.
So absolute max of 4.5 at x equals 0. Yes? Because we have our lovely little endpoint there. What's the other one you guys are writing down that you may or may not want to write down?
We don't have one.
We don't have one.
Yeah, because there's a. Dang it.
Can we?
What's the catch?
Oh.
It's from.
This one that you guys are calling a min is not actually an existing point, is it?
No.
Okay. So in terms of that, we don't necessarily know what we can't state what that absolute value, that absolute minimum point is, because it is something really, really close to. Is that at 1?
Yeah.
But it's not 1. So that absolute minimum would be like 1.000000001. But we can't even state that because there'd be an infinite amount of zeros in there. Okay? So at this point, because it is an open hole, there is no absolute min. Okay? And that's because of the lovely little hole. Okay. C. Why does EVT not apply here?
Discontinuous. 0, 4.5.
And absolute
Okay. Well, here's the deal. EVT says it must be closed. It must be continuous on a closed interval. This would be continuous from 0 to 3 as an open interval, but it's not continuous on closed. Does that difference make sense?
Yes.
So I'm going to say not continuous on closed interval because it doesn't exist at the endpoints.
And there are no.
Our max that we want to say is a hole. Our minimum, it's going infinitely down.
I don't understand the open close thing.
Okay.
Or, no, closed is, there's 2 specific endpoints.
Open is.
Like this one. This one is a closed one. Like perfectly closed.
So
This one.
when we use closed, so, okay. When we talk closed, it is brackets A to B, as opposed to an open interval,
Which is the parentheses.
which is parentheses. This one is end and end. So we would be talking about the closed interval. It's just, so if you ignore the gap here, right? If we ignore that gap in the middle, this would be a closed interval.
So is this one like one side's open, one side's closed?
They're both open because this one has a whole is an open and then an asymptote. We're not going to touch 3. We're getting closer and closer and closer to 3, but we're not going to touch 3, so it's an open interval.
So it has to be closed for it to be.
According to our theorem. And this is where you have to, it's kind of like dot your I's, cross your T's.
So then, like for D, it's gonna be not continuous on closed interval too, right? So there's two.
Right. Again, because we have 2 endpoints. So doesn't mean maxes and mins don't exist, but EVT does not officially apply because
There's 2 open orders.
it's not a closed interval. Okay. Does that help?
Yeah.
What do we have going on though?
An absolute max or
Absolute max.
maybe it is.
Oh, I put it at 1, but that is definitely
Okay,
not at
1.5.
1. It's like, oh, I said 2.5.
Probably 2.5.
I have 1.2 written in my notes. Yeah. 1.1, 1.25. Are we in the ballpark?
I just put 1, which is wrong, but I don't care.
And did you say absolute min?
Yes, negative 1 at x equals 2.
Okay. Okay, extreme value theorem gives us a knowledge of when extrema occur, but how we'll find them algebraically when given an equation only without the benefit of a graph. So our next question should be, how can we identify all the values of x where extrema values occur? Okay, where am I at? Not where I need to be.
Over.
Not where I need to be, but that's all right. Well, we're gonna make this work somehow or another in the next 2 weeks. So
We get all this done. We don't do homework. Then we do the
Well,
whole other lesson.
what's probably gonna be is I go ahead and start teaching
Or
5-3 tomorrow, and I just won't give you work time instead.
we
And
just do
so-
half of it.
But
We do 1 page.
okay, let's see. Example 5. Can I start talking about this one? Which one is this? For each function shown below, justify why the EVT can be applied or why it does not apply on the given interval. Well, I got A pretty easily. That's me. That's the math teacher.
I mean, it's continuous, isn't it?
There's a discontinuity at x equals 2.
Okay, so why is it not continuous?
Because there's an asymptote.
There's a denominator of x minus 2. That denominator is either indicating a vertical asymptote or a hole. If there's another x minus 2 on top, it'd be a hole, right?
Yeah.
But just setting the denominator equal to 0, that's a vertical asymptote. So this is not continuous at x equals 2. Is 2 in the given interval we're talking about?
Yes.
It is. Now, if it was outside of the interval, it doesn't matter. But, so for this reason, EVT does not apply because of that, okay? Yeah, EVT does not apply between -4 to 4 because f of x is not continuous at x equals 2, which is on the given interval, okay? So yeah, we can do A. So it does not apply on the interval -4 to 4 since f of x is not continuous at x equals 2, which is in the given interval.
Is that a vertical asymptote? Yeah.
Yes, it would be a vertical asymptote.
And then horizontal or whatever.
My horizontal asymptote here would be 2 because the powers match, and then you use your leading coefficients, right? Okay, so obviously we're stopping there. My plan to try and get us on track here to end where we need to this semester is to continue 5-2 tomorrow, probably go ahead and start 5-3. Now that means 5-2 homework. I don't feel like it'll be due tomorrow because we don't know quite enough. So they'll put 5-2 homework, probably due on Friday. You can go ahead and start working on some 5-2. but we'll have to talk about the rest of the notes before you can totally finish it. Good enough? Okay.